Hello, and welcome to Human Tech, a podcast about humans and technology. And today we are going to be talking about maybe things in the past. Susan has a really good name for a title. Hello, Susan.
Hi.
What was the full length of the title of the podcast today?
I tend to call it a historical review of human-computer interaction.
Yep, that's a good one.
And
review,
review is spelled R-E-V-U-E, like a musical review.
Okay, if you say so. I didn't know that was spelled differently.
I think it is, yeah.
Okay.
Yeah,
So
it's really fun, I think, to just sometimes stop and look back on where we've been and where we've come from, because I think sometimes we get really excited about, where we're headed with technology or what's going on right now. And then when you look back, you realize, wow, I was really excited about this other stuff. And now it sounds really bad. So it just kind of gives you an interesting point of view.
All right. So let's we have a wide audience. So why don't you talk a little bit about your field in particular, and then you can get started into the history.
You mean human-computer interaction?
Yeah. To you? What is that?
What does that mean?
What does that mean?
HCI. Or some people are calling
HCI.
it, yeah.
Well, you're going to have to give the whole thing and the different names.
Yeah.
Go ahead.
Some people these days, by the way, are calling it HTI, which we've started calling it, but I forget, and I sometimes say HCI. And HTI is human technology interaction, because of the idea that what we're talking about now as we move towards, the Amazon Echo and Siri and dealing with robots. We're not just talking about computers. We're talking about technology. But anyway, the whole idea is that you've got people and you have some kind of technology, and you have that interface or that interaction between the two. And that point, that place where the human is interacting with the machine or the technology is a really important spot, and it's important to pay attention to, and it's important to design that interaction. And so that's where the whole thing came from. And wow, if we go into a brief little history of the field, it actually goes back to another field called human factors, which started probably in the 1930s. When, and different people have different histories and stories, legends about the origins of the field. But here's what I say. You have this idea of studying humans and how they interact with stuff. And some people include back in the 1930s when researchers would show up at the factory and take notes on, how long does it take someone to do this particular task on the assembly line, and they would time it, and they would look at their physical movements, and so if we made the knob for that machine a little larger, a little smaller, it would make it easier on the human, or it would make it go faster. Mm-hmm. And so this idea that you can and should design machines so that they better fit the people that need to use it. So that's really the origins. Now,
so I just want to contrast that with a modern story.
Yeah.
I was at a talk, or I heard somewhere, I forget where I heard this example, but Amazon was, I think it was Amazon. Maybe you know this story. So they were investigating. There had been an incident in which a worker had gotten his hand stuck in a roller. Mm. Packages are rolling through, and he'd got his hand stuck in a roller. And so they did the incident report, and they asked the why question.
Yeah.
So why did his hand get stuck in the roller? Well, because his backpack had fell and he went to grab it.
Right.
So then they asked why. Why did his backpack fall? Because he was putting it on the conveyor belt. Well, why did he have his backpack on the conveyor belt? Because there wasn't any other place to put it.
Yeah.
So they used this information then to put tables to give all the workers little stands so they could put their belongings.
Yeah.
To make everything work.
Yeah, and I think
that's a modern version of
the initial
assembly line.
idea of human factors is that, and in fact, there is a history of human factors concerns coming to the forefront when there's an accident or when someone loses money or that kind of thing.
Yeah, when people care.
And that's when people care. But the idea being that, well, you could care before that. You could just, be proactive and look for situations like that. So that's kind of the whole human factors realm.
And it's funny because a lot of the human factors ties in, especially with machinery. For those of you who don't know, I actually know a fair bit about industrial processes a little bit. Maybe not. I'm no expert, but for a year or two, I actually worked down in Houston for oil companies, and as part of my duties, I basically did inspections of like plant inspections of various suppliers. So our team would go in and we'd literally walk through the shop floor and look for problems and make sure everything was under compliance. So it's interesting because a lot of the safety stuff and there are. Do you know the ISO specifications?
Sure. Yeah, there are, and there are.
And they have a quadrillion of them.
And they have ISO specifications for human-computer interaction.
Yeah, and it so a lot of those, like I did a lot of ISO 9001.
Yeah.
And then there's 14001, which I think is the safety one. But anyways, so it's really interesting. So that and was it Six Sigma and a lot of the warehouse Japanese Toyota car, from the 80s, the car manufacturer, consistent improvement stuff. It ties in very closely with, I guess, the ideals of human factors.
Yeah, so the whole idea,
they're brothers.
Yeah, the whole idea is that if it fits the human better, then everything is better. So you'll be more productive. You'll avoid
and you just try to
errors.
Continue to find improvements.
Yeah, and this became even more in terms of how this directly ends up being HCI or HTI. A lot of it is often driven by the U.S. military is one place where there are advances. So in World War II, you had this increase in technology being used in the military. For instance, just the idea of airplanes, right?
Yeah, you gotta fly an airplane and then fire.
And fire with it, yeah. And
can I tell you, when you finish, I actually have an airplane story for you.
Well, you want to tell it now?
Okay, sure. So in World War I, there been airplanes, but they were mostly used for like reconnaissance. And then World War I, the other side started having airplanes. And they realized that they needed to shoot at the other side with their airplanes. But there's no real way to do it. The old airplanes were hard enough to fly literally as it was.
Right.
And in fact, early in World War I, we kind of think of at least like the Red Baron and the little dogfights that they would have. But early in World War I, the planes were much closer to like the Wright brothers, like wooden aircrafts, and they made pretty big strides fairly quickly. But the problem that they had is they still had they couldn't fly the plane and aim the gun at the same time.
Yeah.
It just wasn't a thing that they could do. So originally in World War I, the pilot would literally open the window and shoot at the other plane with a pistol.
Well, that makes sense.
That was the first one. And so then they realized this literally was doing absolutely nothing. So then what they did was they put guns on the wings. But the problem was that the guns couldn't aim. It was just a machine gun bolted on the top of the wing. And so what they ended up doing was they made the propellers out of like steel. And they literally just shoot the gun through the propeller. And every once in a while, the bullets would hit the propeller blades, but whatever, they were made of metal. And then you just kind of point the plane towards the other person.
Wow.
And they'd fire. And then now eventually they figured out, oh, okay, we're gonna put them on the nose of the plane, and that way you can just aim. And then of course the big step was then making a gun that you could pivot and move and point at the other plane. But there wasn't a good human interaction, so that you could fly the plane and point the gun where it needed to go at the same time. It just didn't exist. So.
Yeah, well, and then the other thing that compounded, and the other reason we often point to World War II as kind of the beginning of our field, is because you had, not only did you have advanced technology and more, in World War II, even more complex planes, but now you had people being drafted into the military who didn't have specialized training in any of this stuff. I mean, planes or guns or tanks or any of it, and you had to teach them really fast, right, how to use this stuff. And so this whole question of, okay, how do you get someone to learn how to use this, and how do you get them to use it safely, and became even more important. And so that's really when this field called man-machine interaction, because you didn't have women, you just had men, and that's when that started, and the realization, the understanding that if you're talking about taking people who don't know civilians who don't know anything about this, and you're going to have them use complex equipment, maybe we'd better get psychologists involved. So that was really the kind of the beginning of the field. Now, what happened after that is it kept changing, and then it was called human machine interaction for a while, and then computers came out. Right, computers came on board, and we're going to talk about kind of the history of that as well. And when you get to the point, especially where not just computer scientists, but everyday people start using computers. So that's in the maybe early 80s, mid 80s. That's when you really get this a branch of the whole human factors and man-machine interface, all of that work. A branch starts up called human-computer interaction. The understanding that, well, yeah, we have all these other machines, and by the way, those two branches kind of kept going off in their own offshoot, kind of their own evolution. So there's still human factors in machines, and I visited once a human factors lab for that made all the controls in a car, like the knobs and the sliders and for the radio and the air conditioning and the changing gears and all of that. So there's a whole and that was really fun. I mean, they get into okay, so you got a dial that you're going to turn on your sound system in the car. So when you turn it, should you feel the notches? How much of a feel, and how many notches, and how big should the knob be, and all those questions. I mean, that work still goes on, and that's one branch. But then was this offshoot of just about computers, and that even got even smaller in a way because it turned into an offshoot of the design of computer software and screens and even, I mean, when you're designing, whether you're designing software or an app or a website, you're not really designing anything physical, right? It's all imaginary. But that whole thing became its own thing. And that part of the human-computer interaction specialty really started, I would say, in the mid-'80s and has continued, on up to the present. And so that's what human-computer or human-technology interaction is. It's the idea that there is an interface that the human deals with in dealing with the computer or the machine or the technology, and you want to design that so that it fits the human. Now, it started off as a easy to, you want to design it so it's easy to use.
Yeah.
And then it turned into, and actually, I think this is partly my fault. It turned
you personally?
Yeah, me personally. It turned into, not just you make it easy to use, but make it persuasive, make it engaging, make it so people will take the action you want them to take. I think that's my fault. So I claim credit and I apologize at the same time for starting that whole branch. And then it went from name-wise, it went from, like human-computer interaction to usability kind of came into vogue. And then user experience is a term that's pretty much used now.
Yeah.
But so that's that whole, actually, that's not what I thought we were going to talk about on this podcast, though.
No, that was literally just the intro to the topic.
That was a really long intro.
Well, you kept going. So.
But that does you're right. It places it in perspective. But I was going to talk about just some of the...
Yeah, so now that we've laid the foundation.
Yeah, some of the old ways that we actually did interact with computers back then. Now, of course, you and I are both way too young to have personally experienced any of the things we're going to talk about, right?
I don't know.
Well, that was a joke. You're too young. Unfortunately, I experienced a lot of these.
Maybe in my off time, I use Punchcards on my loom machine at home.
You might.
How do you know
I
what
don't
I do
know.
with my free time?
Yeah, so some of these...
I have my loom machine right here next to me, actually.
So some of these technologies that we're going to talk about, I may not want to admit that I personally use.
Okay.
Because it would
it
would date me, and I don't want to do that. But so if we just talk about, and some of the people listening out there, it depends on when you got started with computers whether you know about these or not. Right?
Though just as a note,
yeah.
Recently in the young cool urban community.
Yeah.
And I'm using urban literally in the city sense, not the cultural sense. There is a brand new wave of people thinking analog is really cool. So of course,
it's retro,
huh? Yeah, well, a small subset is the vinyl people, but much larger, the steampunk had its heyday, and there's using machines and actually do things.
Well, it's interesting.
So you say that people probably never experienced this, but
maybe they have.
You might be surprised.
When I recently went to buy a new keyboard for my office, right?
Perfect example.
I had no idea. You told me. You said, well, maybe you want a mechanical keyboard. And I was like, what?
Yes.
And, to me, a mechanical keyboard was a throwback. It was, like, why the heck would you want to get a keyboard that went clackety, clackety, clack?
I'd just like the audience. That's
like that.
So there is I subscribe to a subreddit called Mechanical Keyboards. That's literally just about how great mechanical keyboards are. And the almost universal consensus is that whatever, like the IBM keyboard in 1986 was like the greatest keyboard ever. That there's never been a better keyboard.
Yeah, that's so funny because...
And in fact, when people find like old ones, like in basements and stuff, they post on there and everyone's like, oh my God, it's so great.
Yeah, I probably have a couple of those in my basement.
Really? Honestly, they might be worth like a couple $100.
Oh, now you're telling me. I think I know I had like a lot of them because I had a training room with computers.
There's like a whole group of people who are just gnashing, rolling over.
I think and we, back in the day, we were very happy to get rid of those. I think we didn't we call them, chiclets?
No. You're getting your terms confused.
Oh.
A chiclet computer, if I'm not mistaken, is the kind of MacBook laptop with just the black squares. I believe that is what is referred to as a chiclet.
Anyway, we used to make fun of the old IBM keyboards.
Well, they were very noisy, and the sound you heard. So I use Cherry MX switches, and Cherry's been around for forever.
Yeah.
But they make them in different colors. So red is like the gaming one that makes like no noise.
Yeah.
I use brown, which is in between, and you can kind of hear like a bit of a click clack when I write.
Yeah.
And then there's blue, and blue is basically kind of closer to the IBM ones. It's like it's like really like
loud.
every time you press, it's really loud. So mechanical switches are deemed superior for a lot of different reasons, and I don't want to get too much into it.
So
but the idea that it's
and I ended up buying
digital.
I ended up buying one, but
you like it.
I do like it. Yeah. I also like my non-mechanical.
You can type more. You can type quicker and more fluidly on a mechanical keyboard.
I'm not sure about that. Anyway,
more accurately.
But as we go through, then talking about some of these old technologies, then we're saying they might come back.
So I was just wanted to say, you just said no one will have any experience interaction with them, and I'm going to be like, not so fast.
Yeah, because some of them come back. All right, well then let me ask you this. Yeah, you were joking about your loom and the punch cards. So one of the early ways that people communicated with computers
was punch cards.
Punch cards, yeah. So
all right, so tell. I don't think punch cards have come back, but so why don't you explain? Do you want me to explain punch cards? Do you want to explain punch cards? How they work?
I'd like to hear you explain them, and I'm going to see if you're right.
Okay.
Or if you don't want to, I'll do it. But go ahead.
For the record, I have never used a punch card in my entire life. So basically, the way a punch card works is you literally think of it like a card, right? Think of like an airline ticket, okay?
Yeah.
Now on that airline ticket, there are a bunch of like holes on it in random spots, punches, as it were. Now, you hand that to a computer, and the computer looks at each little space, and if there's a space there, then it knows to do something. If there's not a space, right, then it knows to do something else. So either having a hole or not having a hole creates the 1 and 0. You could think of, for example, a voting booth would be the simplest version, right? Where you literally punch a hole. If you remember, like the Bush v. Gore hanging Chad debacle, right? So a hole means that something happens, and no hole means that something else happens. We'll do that on a much more complex level, and you have a punch card. Now, I don't know how it read what to do, and if I'm right at all. So
yeah, I mean that's pretty good, and I'm not a computer hardware person either, so I'm not gonna.
I'm a computer hardware person. I'm just not a punch card hardware person.
I'm not an old computer hardware person. So, but yeah, I mean basically you're right. You had these cards, and there were lots of little places. where holes could be punched through it. And that would, if you think about, binary numbers, right?
Yeah, and just as a to back up a little, the entire goal of all computer hardware is to essentially get things into binary code, one form or another.
And that's all
or floppies or
that's all the cards were
drives
doing.
of the internet.
They were just the code. So what you would actually do, you'd have there was these big big things it's like a typewriter the size of a piano kind or a keyboard, and the cards were empty cards, blank cards were just stacked up ready to go, and it would shoot one in to the machine, and then you would actually type on a very mechanical keyboard, and you would type like someone's name,
Now we move forward. So just to back up, the first punch cards were used in the 1800s?
Yeah, you're right. We should back up. The first punch cards were used in the 1800s.
So real old.
Looms. For looms, yeah.
And a loom is, for example, if you're making a carpet, a fabric, right? You use a loom to weave fibers together in a certain way.
Yeah, and the punch cards would control
which fabric went
which yarn.
Right.
Okay, so now we're going to use
but no, we're not, but this is pre-digital anything.
Pre-digital, pre-computer. This
isn't even a computer. You're basically just using a punch card to control a machine.
To control the machine, right. I saw these. I went to this wonderful textile museum that I highly, highly, highly recommend if you happen to be in Lille, France. Lille, which of course everyone just happens to be in Lille, France. But actually, this museum is so good, you should go to Lille, France, just to go visit it. And they gave an amazing tour of the history of textiles and the history of the looms, with the looms right there. So this isn't a museum where you just walk around and look on your own. They have all the machines there, and someone takes you through, they run these machines. They actually use the machines from hundreds of years ago. And the reason they do this in Lille is this was a huge textile center for hundreds of years. So it was great. But I was very surprised to see there these extremely large and complicated punch card systems, and that controlled the yarn, and therefore you would program. They said it took like 4 years to program the cards to run a particular pattern of fabric. So it took 4 years to program that. Once you had it, of course, it meant that you could produce this pattern of fabric, over and over and over again. So that's where punch cards came from. But in the use of computers, you would type your numbers or your computer code, your lines of code, your data. You would type them on a keyboard, and that would translate, like you type the letter M, and that would translate that into the code,
machine code
for an M, and punch that on the card. And then you would have,
and note, it would not punch an M on the card.
No, it wouldn't.
It would punch the ASCII.
The ASCII code, the series of holes
bits or bytes
that means an
M.
M. Yep. And then you would take your cards to a machine called a card reader, and you'd have a stack of cards. Now, you can imagine that, so you could run a program this way, or you could input data this way, you could do both. And you can imagine that, you'd have a lot of cards. I mean...
Now, hold on.
Yeah.
Now, I'm just going to give a question, and then I'm going to give the answer, right?
Yeah.
So some of you might be thinking, well, wait, why would you have to, if you could just type it in...
Yeah.
Why don't you just type it into the machine to start with? And that is because there was no way to store data. The idea of memory didn't necessarily exist. You could only store very, very, very small
really
amounts
small
of data.
amounts.
We're talking like a couple sentences, maybe.
Yeah.
right? Like 100 bytes,
Yeah,
1,000
and in
bytes.
fact, when you would run the cards through the card reader,
Yeah.
it would take some cards, and then it would stop, and it would think,
Yeah. So like,
and then it would take some more
this
cards.
idea that you could just on a computer, right? You just type and then it shows up on the computer. Is that it has so many assumptions. When you type, it's just sending little bits of electrical data. That data has to go somewhere and has to be stored somewhere in order before it can even be processed.
Yeah, yeah.
So that's why you needed
Yep.
punch cards.
So
because there was no way to store electronic data.
yeah. So you worked with cards. You would have, one program might take boxes and boxes of cards, and you would cart them over, and you literally cart them over like on a cart because the
Well, yeah, they were metal.
what?
Were they metal or paper?
The cards?
Yeah.
Oh no, they're paper. They're cardboard.
Oh, okay.
But
Okay.
the thing is, the computer was in a special building. You didn't have your computer next to you. You had to go to the room where the computer was, and in fact, you weren't really in the room with the computer. You were in the room with the card reader, and the computer was behind that wall. Sometimes there was glass, and you could see the computers whirring around.
Yeah.
And
So just to get an idea of things. So back in the day, before transistors existed, you had your old vacuum tubes.
Yeah.
Right. And so, right, when we think of you have a bug, well, that's because a moth would fly in a vacuum tube and cause it to short, causing the problem in your code, right? So that's where the phrase comes from. So back in the day, the way computers worked is each bit, and again, a bit would just be a 0 or 1, right? So that's one bit. It's either on or off. 8 bits to a byte. I believe 4 bits is a qubit, if I'm not mistaken. I think like 2 bits is a bittle. I forget about the 2 bits one. Anyways, so each vacuum tube was about the same as the vacuum tube that was in an old CRT television. So it's maybe the size of 1 or 2 apples, kind of next to each other.
Mm-hmm.
That's 1 bit. Now, a normal ASCII letter takes a couple bits, right? So if you typed A, you're taking up the size of, maybe a 1 or 2 square feet, right? So
yeah,
right,
it's
maybe
hard.
like the size of a microwave.
It's
just to
hard. It
store
really
the
is
letter
hard to
A.
understand. I mean, you see these pictures, these photographs, of computers back in the, let's say, the 1960s, 1970s, and they're gigantic rooms. I mean, just gigantic rooms.
Well,
where,
yeah, because if you needed enough memory to store a sentence.
Oh, yeah.
you needed a huge amount of space.
huge, and they
and
would,
electricity.
they didn't. I mean, they had. There's no machine we use today that had that little capability that was in that gigantic room. I mean, it was just. Yeah, well,
So that's why you had the big machines in the different
That's
rooms.
right.
Like literally, you had to have these vacuum tubes
Yeah.
made of glass
Vacuum
in order
tubes.
to house information.
Yep.
Okay.
Even when you went to transistors, the machines were big. All right, so then we went. So that was our initial way of interacting. There was also a time in there where you could. There would be like like they strung the cards together, and instead of having to use
Like a machine gun.
cards, there was like a roll, almost like a player piano roll, and you could actually store things on rolls. That was better because it could get rolled up, right, rather than having all these separate cards. So we went to that. Now, then the next wonderful improvement was you could talk to the computer on what was very much like a teletype machine, and the computer could talk back to you. So it's just a machine. Well, I say teletype as though anyone would know what that means. This is like a typewriter looking machine that you could type on, and when you typed on it, that sent the information to the computer. And then when the computer wanted to give you an instruction back, the machine, this typewriter kind of thing, would start like typing on its own, like a player piano. It would all of a sudden and it was very noisy, and then words would appear on a piece of paper. So you were talking back and forth to the machine through the typewriter, and that was very exciting because then you didn't need to do the cards necessarily.
And it makes a lot of sense because, right, so the computer was working in machine code. The human is working in human code, in letters, essentially. But to make the letter-to-machine code translation, you need a very complex, very expensive typewriter. So why have one for the human and one for the computer when you can save money? You just
have one.
Just have one.
Yeah.
And it's actually, that's interesting because that's actually a more direct communication with a computer than I think than we had for a long time.
Well,
now we're
but
getting back to that.
Yeah, but you only used that for certain things, and then everything else you did what was called.
And by the way, when we say talk, and the computer would talk to you.
Yeah.
It's not exactly.
No, we don't really mean
Siri.
talk.
Yeah, it's.
And if you were running
very basic, like if you gave it a math problem, it would type you.
It would type an answer. But if you were running a big program, you would run it what's called batch, meaning you wouldn't talk to the computer that way. You'd go back to the cards, and then a piece of green paper would appear with your answer. All right, so that was that. Now around 1969 was the first commercial computer screen that came out, and this was a screen actually with a keyboard attached to it. It was called the data point. And now, instead of the teletype and instead of cards, you could just type on this machine, and it would talk to the computer, and the computer would talk back to you, and this was like miraculous. Now,
and much cheaper.
Yeah, and these were called, sometimes it's referred to as green screens, which is really kind of weird because actually the screen was black, but the letters were green. Yeah. If you were very fancy and had extra money, you could get an amber screen. And it was called amber. I don't know why, and it had orange letters rather than green letters.
Amber letters.
And that was supposed to be better for your eyes, although I doubt it. And everything, initially everything just scrolled up from the bottom, right? And then we got to the point where we could show a whole screen worth at a time. Now this is pre-graphical user interface, right? So this is not pictures of any kind, it's just words. And when you wanted to like if you had a form that people were going to fill in.
No mice.
No. This is pre-mice. If you had a form that people were going to, you wanted people to fill in a form like with name and address and all of that, you could actually use your asterisk key to make a box around some of the fields. That was how you made a box, by typing asterisk, 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 asterisk. That's the kind of thing.
Emoji art.
Yeah, really, it was. And that was as, complicated as you could get. But when we got into this whole idea of showing a screen at a time and then using special key presses to go to another screen, and this was when we started developing menus of things. So this is really when the whole idea of designing software so that it would be easy to use. This is when that all came out, because at that point you had the programming group who did not think at all about what this was like for regular people to use. They were just trying to make sure that the numbers would come out correctly or the data would come out correctly when you ran the program. So for a while there was no one developing the interfaces, and they were really difficult to use because basically you had a programmer just doing, I'd have the screen look like this, but regular people were not used to dealing with this, and the programs were hard to use, and there were lots of weird acronyms, and you couldn't find anything, and it was pretty usability was not well known. And I actually remember when there were a handful of people like I could count on two hands the number of independent consultants that worked in the field of what we would now call user experience. Now, within some companies, if you were very high tech, like within IBM, within AT&T, there would be departments of human factors, human computer interaction specialists. But in terms of if you were not a high tech company, if you were like an insurance company, if you were whatever your business was, and you wanted to design software that was easy to use, which was a very foreign idea, and that would mean you were really futuristic thinking if you cared about that. You had to bring someone in from the outside, and there were like 12 of us in the U.S. Like that was it. So that was a long time ago. Okay, so
field has exploded since.
Yeah, it has exploded since. So then you had the Palo Alto Research Group, PARC, and they were thinking about new ways that people might interact with computers, and they were the ones that came up with the mouse and with drag and drop as a whole idea.
And then once there was a graphical user interface, everything just exploded.
Do you know what drag and drop means? If I use that phrase, is that a commonly understood phrase?
Yes.
Okay, well, I didn't know. All right.
I would say, well, people are very familiar with the idea of clicking something and dragging it around the screen.
Yeah.
Right, to move it.
Yeah.
Dropping, not so much.
Yeah, when it first came out, it was called drag and drop because it was so wild an idea that you could grab something and move it over to somewhere else and leave it there.
Leave it there. Yeah, I would say people would just the drop. People probably are familiar with the phrase. They would if you say you could drag and drop things around the screen. I think everyone knew what you were talking about.
Okay.
But I think when they think about it, people would just say,
think of it as dragging. Yeah.
The idea that, of course, naturally, when you let go of something, it stays exactly where you put it on the screen in the exact dimension.
Yeah, that was a big deal.
Well, of course, that's what happens. Yeah.
So with the, that was called the graphical user interface, or GUI. By the way, the green screen one, it was called a character user interface, so we call it CHUI. So we had CHUIs and we had GUIs, and that changed everything yet again when you could actually have now, instead of just asterisks, you could draw boxes, you could group things, you could have illustrations, you could have pictures. You now had mice, in addition to keyboards. You had trackballs came out, as a way to interact. Track pads came later, and so
I always liked trackballs.
Yeah.
Yeah, they were cool.
So the whole, then this whole idea again of making the products usable became a little more popular. That became a little more important. And again, you're also expanding the universe of people that are using computers. And the whole idea of more complicated navigation and so on, so that became that was a big deal when the graphical user interfaces came out. And then the next big deal, of course, was the internet. Which, here's an interesting thing to think about. When the internet first came out, and you had internet applications, the human-computer interaction portion of that moved backwards initially. Backwards. So before the internet, when you had these graphical user interfaces and you had the capability, for instance, of clicking on a drop-down and having a list appear, you know what I'm talking about, right?
Yeah, sure.
Well, before graphical user interfaces, you couldn't do that. You couldn't do that on a character user interface screen. You couldn't drop something down. There was no dropping down. You just had to know the code for what you were trying to do, and you would type in the code. So when the drop downs came out in the GUI, that was a big deal. And one of the reasons if you really want to get esoteric here, we can start talking about the fact that when you click on a drop down and choose an item from the drop down, that is using recognition memory. When you are staring at a screen and you have to type in a code, that's using recall memory. And recall memory is harder than recognition memory. So on some podcast coming up here, we're going to have to geek out on this stuff and really get into all the little esoteric things of human-computer interaction. But anyway, that's why GUIs were so much easier than Chewies. But when we first went to the internet, we did not have the software and programming capability to do a lot of the things that we were used to doing on our GUIs. We could not do on in internet applications. So the internet applications were almost like going back to the Chewies at first. You couldn't, just refreshing the screen was a big deal. There were no window pop-ups on internet screens initially.
Sure.
You had to refresh the whole screen. You couldn't just pop up a window, which meant you couldn't remember what was there before.
And on a technical level, this is because, so today we have very advanced client-to-server communication that happens all the time.
Yeah.
And like PHP script. But we also, which is still complicated today, it's really hard to do. But more importantly is today you can load basically an entire module and then do things on the client side. So that's like JavaScript, right? So we're going to load all these things, and then with JavaScript, you could do things locally.
Yeah.
Right? So you could, so like when you talk about menus popping up and drop downs and all that kind of stuff, that's all JavaScript. So the page loads, it loads a file from the server, and then it's not communicating back and forth every time. So then you can actually do like drop downs and stuff on the client side. You can have an interface. But before that existed, the only way to change the screen was to go to a new page, which meant talking to the server, which was very slow, and you had to refresh the page.
Yeah.
That's the tech background.
Yeah. No, and interestingly, we had the same thing when we went from, because initially we had mainframe computers, big computers, and the only thing you had hooked up to it was a terminal and a keyboard. Like there was no smarts on your desk. Mm-hmm. Everything went to the mainframe computer behind the big wall, right? And then we had PCs, right? So where the computer was, right there at your feet, right? So things were faster. And then we went to the internet, which is like, it's like going back to the mainframe, only the mainframe is really far away and you don't even know where it is, And then we went to this in-between place where some things are done on the mainframe and some things are done locally, right? So we've been going back and forth like that for years. Now, one of the things we haven't talked about yet, and I should back up a little bit in terms of the human and computer interaction or human to machine interaction, has to do with size and storage. I mean, there were initially, when the computers came out, when personal computers came out, when you could get your own computer on your own, in your own space and not connect to a mainframe, you had to have some kind of storage. Now the storage on the mainframes were these, huge, initially tape and then these big drum disks. But you couldn't have one of those at home. So you had these, they were called floppy disks because they were floppy. They were 8 inches by 8 inches. And if you could wave them like a fan. And all your stuff was, that's how they were floppy. And they were, all your stuff was stored on these things. And, if you had one of...
It's just for those of you who don't know how floppies work. There was this tape, okay, called magnetic tape, and it was a really long roll. Think of it like a film reel, except on each little part it was full of little it was again magnetic tape, and you could make the bits either 0 or 1, right? And then the machine would read the tape like a punch card, like the punch card rolls as 0s and 1s, except it was much smaller than punch cards. A floppy disk is nothing but magnetic tape that exists in a spiral pattern like a record. And so the floppy rotates, and the little laser, well, I don't know if they don't use lasers, but back then the basically the magnetic field detector would detect if it was a 0 or a 1 on the floppy. And that's how floppy.
If you had one of the,
it's the same as a CD, except
if you have one of the
magnetic
really
tape
big,
inside.
like double density, it could read one side and the other side if you were lucky enough to have that.
Big version.
It held 360 KB of data.
It's a lot of data.
KB.
It's a lot of data.
It is not a lot of data.
That's,
All right, and then portable computers came out. That was a very big deal. Now, these were not laptops per se; they were portables. They weighed 40 pounds, and you would close them up with latches, and they had a handle, and you could like pick them up and carry them. Very, very exciting. And when you opened them up, half of it was the screen. It was we were amazed by the technology. It was just amazing. And then, of course, the floppy disks turned into, people still call them floppy disks, but they weren't floppy any longer. They were the 3.5-inch
sure.
little things.
Well, they were floppy. They were just solid on the outside.
Solid on the outside, yeah.
But the inside, the magnetic tape.
So, that all this technology, and so there's been this evolution in the capability of the software, the capability of the hardware, but always this, always having that intersection point of how do we design this so that the human can, figure out what to do with it. So now, if we just kind of zoom forward into the present, we still have screens, although they're bigger sometimes, or they're smaller, right? So we ended up with getting a lot of diversity in screen size. We'd still do a lot with keyboards, whether a physical keyboard, or whether we're typing on a part of our screen on a smartphone, right? We still have mice, although now we have touch screens, and we're starting to flirt with gestural interfaces. So in some ways things have changed a lot. In some ways they've stayed the same. But yeah, you're right. The need for people to design the software so that it would be easy to use, or design the application, that's what really did explode. And I remember the moment. Okay, I remember the moment where I realized how big the field of user experience was going to be. And it was before the word user experience was around.
Yeah.
I was teaching usability courses, how to design software so it's easy to use. And back then, I used to periodically go take programming classes so that I could understand what was the current state of the art of programming. Because a lot of what I had to do and the projects I was consulting on was I had to work with the programmers and developers.
Right.
We had to interact, we had to negotiate, and it helped me if I knew what was easy for them and what was hard for them. So if I said, well, let's do it this way, it helped if I knew that what I was asking was just a big pain for them or a piece of cake. So I used to go and and take classes in the latest tools, so I would kind of know what I was doing.
Latest tools in heavy quotation marks.
In heavy, that was the latest back then. So I remember I was in an object-oriented programming class,
which today still exists. Still is rattle. It was before Swift came out. All the iOS applications were written in Objective-C.
Yeah. So this was kind of
C, but with objects.
So this was, there were a number of different object-oriented programming languages that you could use, and this was, object-oriented programming that came along with the graphical user interface. Those two went hand in hand, and so I wanted to better understand whatever this particular programming tool, and I don't even remember what it was, but a lot of my clients were using it. And so I went to this 3-day class and filled with, everyone in there was a programmer except for me. Like, I'm the only usability person in the room. And we had a partner, and we were doing these exercises, and where we had to design a program to do this or that. And I thought I was doing just fine. I thought I fit in well, until at one point my partner, turned to me, and she, because see, what I was doing was we were designing this thing, and of course there were two pieces to the design. There was what's it going to look like to the person using it, and then there was underneath the code, right?
Right.
And being a usability person, I was, probably being obsessive about what it looked like, and being the programmer, she actually didn't care that much about what it looked like. I mean, I'm not saying all programmers were like that back then, but a lot were. And so she was apparently getting really frustrated working with me as her teammate for the 3 days, and I didn't realize it until she pounded her fist, which I will not do right now because it'll make too loud.
No, go ahead. Pound away.
Pounded her fist on the table during the exercise. Everyone in the room turned to look at us to see what was going on. And she said, "We don't have time for this." Because I was again wanting to make yet another iteration to the design of the prototype. And that was a huge aha moment for me. Because up to that point in my career, I was teaching and consulting with programmers and developers. Because there were very few usability UX, and UX hadn't been invented, that term. And so who did design? Who designed the interfaces? The programmers, of course. And that had been going on for a long time. And that's who I worked with, and that's the classes I taught, was to programmers on how to design things that would be easy to use. But I realized when she pounded on the table that she was absolutely right. These new tools were just getting more and more complicated, and I realized it was impossible to concentrate on the code and the design of the human interaction part at the same time.
I mean, and it is today, if you look at modern. So there, in the last maybe 10 years, and again, I'm a mild programmer, but I am not I'm certainly not I don't work on modern programming teams. I'm not a programmer by trade. There's been a real change in how people organize and work on a project together. So the whole revolution of, GitHub and the different, assigning different people to work on different tasks, and it all kind of comes together. Modern programs are so amazingly complicated.
Yeah.
Because even back in the day, if you're writing a program to run some actuarial functions or something like that, like, it might be complicated, but the flow is like one human has the capacity to wrap their mind around the different flow. And now with some of these more advanced programs, it's just mind-boggling, just hundreds and thousands of different little pieces that come together to make up a modern program. So so I can imagine before they really figured out how to keep track of everything.
Yeah, it was really pretty tough. It was primitive. So I had that aha moment, and I actually walked out of that class I stayed till the end. I just tried to get some peace with my partner, and but that was a real revelation for me. And when I went back to my office, I changed my whole approach, because I realized that this whole thing, computers, software, human-computer technology, the whole idea was exploding, and we needed people to specialize in, like I was, but we needed a whole lot more, and we couldn't, wait for people to get PhDs and whatever. We had to have an army of people who would pay attention to the design and to the human-computer interaction. And I actually then started a campaign to train hundreds and thousands of people to specialize in this, and talked to my clients, which were for the most part Fortune 500, Fortune 1000 companies. I started giving talks and talking to my clients and speaking at conferences about the need for this, and it really started to grow to where now a user experience specialty is considered one of the best careers to have. So although we could have another podcast just arguing about what the role of user experience is these days, but that was a big change, and now now we do have hundreds and thousands, tens of thousands. I don't even know how many people in the world who are really concentrating on this aspect of design between the human and the technology. So it's we have come a really long way with hardware, with software, with how much we care or pay attention to that human-computer interaction. So there you go. That was the historical review, and I didn't even go through everything, but that was a pretty good brushstroke, wasn't it?
I think so. Just to provide some context to the history of the field. I know we have a lot of fans who are definitely in that world.
Yeah.
Especially younger people who haven't ever really experienced anything pre-graphical user interface.
Yeah. I've often realized that I should have kept all my old stuff, and I could have opened my own museum. But you don't know. That's the interesting thing about all this technology stuff. You just don't realize where it's going to head and where it's going to change and what's going to be interesting to keep and hold on to and talk about, and what isn't.
Absolutely.
And I hope on a future podcast we'll talk about the future.
Absolutely.
So I would like to encourage, Guthrie, if I could, before we wrap up here, I'd like to encourage people to maybe write into us with some of their fun old technology stories and see if we can
sure.
Get any stories.
info@theteamw.com if you have any stories. I guess while I'm doing it, feel free to rate us and do things. Also, I'm going to start saying this more. If you ever want us to come speak at your event, we do that. So just, you can email us, again, info@theteamw.com.
Yeah, we can come. We can speak. I speak, you speak. What we haven't done yet together is speaking. We could speak together.
We could do that. Well, we do the podcast. Anyways, so that all the social media, whatever, follow us, do things. You can check out courses.theteamw.com, also just theteamw.com for everything about us. Anything else you'd like to add?
No, I think that's good.
Yeah, hopefully, just a little primer on all the different the history of things. So with that, I guess I'll wrap it up and